Good morning, friends. We are studying bending stress, so that's why today also I am taking today's last lectures, that is the on bending stress. So please note down complicated problems or the different problems for different cross sections for bending stress. Please note down today's first problem: a cast iron beam has a section as shown in figure. Find the positions of neutral axis xx and moment of inertia about neutral axis when subjected to a bending moment and the tensile stress at the bottom edge is 25 Newton per mm square. Find the value of bending moment and stress at the top edge. Cross section given. This is 120, this is 20, this is 20, total 300. This is 20, 150, and this is again 20. So this is symmetrical about y axis and unsymmetrical about x axis. So that's why, suppose this is positions of neutral axis and this is yt and this is yc. So for simplicity of the calculation, so we can modify the section. So this is 20, 120, 20. Suppose this is top flange and this is 160. this is equal to 160. And this is 150, this is 20, this is again 20, bottom flange so this section equal to 300 minus 180, sorry 120, means this is 180, slightly greater. So this is unequal I section. So that's why this is slightly YT and this is YC. So YC is slightly greater than, suppose this is the reference line. Now this is symmetrical about Y axis and unsymmetrical about X axis. So first we will calculate YT bar equal to A1 Y1 plus A2 Y2 plus A3 Y3, A1 plus A2 plus A3. So first component, and this is 180 area, 180 into 20, 180 into 20, Y1. So this is Y1 equal to 20 divided by 2, because this is half. So that's why this is 10 plus A2, 150 into 20 multiplied by 20 plus 150 divided by 2. So this distance centered above the second element, and this is 20 and half above the 150 plus A3 160 into 20, directly can I yes write 20 plus 150, 170 plus 10, this is 180 divided by and this is YT. So first we will calculate bottom terms. So we can take common 20 into 180 plus 160 plus 150. In the top also 20, 180 into 10 plus 150 into 95 plus 160 into 180. So that's why 180 plus 160 plus 150, 490 multiplied by 20, 9,800 1800 plus 150 into 95 plus 160 into 180, 44850. divided by multiplied by 20. This is equal to 91.53 mm, and YC equal to total 190. This is 98.47 mm. Right? Now, by using parallel axis theorem, moment of inertia about x-x axis, self moment of inertia plus A1 y1 bar, self moment of inertia second plus A2 plus self moment of inertia third plus A3 y3 bar square. So for first section, self moment of inertia. So here B equal to 180 into 20 cube divided by 12 plus 180 into 20 y1 distance. Y1 bar distance means this is now y1 bar equal to, so yt equal to 91.53 minus 10. So this is equal to 81.53. 81.53 square. Second, self moment of inertia now, B2 equal to 20, depth equal to 150 cube divided by 12, area 150 into 20, now centroidal distance. So from bottom side, this is 7595 minus 95, because this is centroidal distance, 95 minus 91.53 square plus 160 into 20 cube divided by 12 plus, now centroidal distance, this is total 170 this is 95, or YC equal to how much? YC 98.47 minus 95 bracket square, because this distance is the y3 bar, similar type y2. Now moment of inertia, 180 into 20 cube divided by 12, 1,20,000 plus 180 into 20 into 81.53. So we are making mistake here, 98.47. So this is y2 bar and y3 bar means this distance. Y3 equal to YC 98.47 minus 10. Minus 10. So I make mistake that 81.53 square 23,929 into 10 to the power 6. 20 into 150 cube divided by 12, 5.625 10 to the power 6, 160 into 20 cube divided by 12, 0.106 10 to the power 6 plus this is also 5 digit 0.12 10 to the power 6. 98 means 88.47 square multiplied by 20 multiplied by 160, 25.046 into 10 to the power 6. 25 point plus 106 plus 5.625 plus 23.929 plus 0.12. This is equal to 54.826 10 to the power 6. So that's why now tensile stress this is given means sigma BT equal to what is formula? M into YT divided by IXX. This is given 25 M equal to, that is to be calculated, YT 81.53 and this IXX 54,826 into 10 to the power 6 M equal to multiplied by 25 divided by 81.53. This is equal to 16.81 into 10 to the power 6. Now sigma BC equal to, so here's what change, M into YC divided by IXX only. So this will get value of the stress at the top edge. So this is stress at the top edge. This is equal to M equal to 16.81 into 10 to the power 6. YC equal to YC 98.47. Oh, sorry, I am making mistake here. So this is not 81, this is 91 point. (25 into 54,826 10 to the power 6 divided by 91.14.97. Sorry, 14.97. 4 multiplied by 98.47 divided by 54.826 divided by this is 26 point, because this length is more, so this distance yc is more, so that's why this yc stresses induced in the top edge, that is greater 26.89. This is the expected answer. So next problems, C section problems that was remaining. So this is different section. So this is inverted T section. A horizontal beam of the section shown in figure. A horizontal beam of the section shown in figure is 3 meter long, and is simple supported at the ends. Find the maximum UDL. Find the maximum UDL it can carry if the compressive and tensile stress, if the compressive and tensile stress must not exceed 55 Newton per mm squares and 30 Newton per mm squares respectively. Draw a diagram showing the variations of the stress over. Draw a diagram showing the variations of stress over the mid-span section of the beam. C section. So I use that space for calculation. And suppose this is positions of the neutral axis. So sigma BT, and this is sigma BC equal to how much? This is 150. This is 25. This is 25, and this is 100. Now, for simplicity of the calculation, so can we change these diagrams as join these two sections? Likewise, means inverted T section. So this is 25, this is 25, this is 25, this is again 150, and this height equal to, we require, this is 25, this is 20, height also we require. Height is given. This is 120. So that's why this remaining is 95. Now this is positions of the neutral axis, and this is YT, and this is YC. So first we will calculate Y bar A1, Y1, A2, Y2 divided by A1 plus A2. So this is first and this is second. Here about the first component, 150 into 25 Y1. So this is 25 divided by 2 plus area of the second component, 25, 25, 50, height 95, Y2, 25 plus 95 divided by 2, because centered above the, this is centered above the second element. So this is 47.5, this is 47.5, and this is 12.5, and this is 12.5. So please, if you are not understand, so try to understand this. And this is 150 into 25 plus 50 into 95. This is second area. One 50 into 25, 50 into 95, 12.5 multiplied by 25, 150, 50, 95 plus, first we will calculate that, 47.5 plus 25, 72.5 multiplied by 95 multiplied by 50 plus 150 into 25 into 12.5 divided by, so this is equal to y bar equal to 46.02 mm. So this is yt 46.02, yc equal to 73.98 yc. Right. Now you can calculate moment of inertia equal to about x-axis axis, because this is not symmetrical about x-axis axis, because this is different above rectangular, and here this is combinations above the two rectangles. So that's why a1 y1 bar square, sorry, self moment of inertia by using parallel axis theorem plus self moment of inertia second plus a2 y2 bar square. First 150 BD cube equal to 150 into 25 cube divided by 12 plus area 150 into 25 y1 distance 46.02 minus 25 divided by 2 plus self moment of inertia second B2 equal to 50, 95 cube divided by 12 plus 95 into 50 multiplied by YC equal to 73.98 minus 47.5. So we'll calculate separately. 150 into 25 cube divided by 12. So this is 19.95 into 1953 10 to the power 5. So we will calculate in terms of the 10 to the power 5. 46.02 minus 12.5 multiplied by 150 multiplied by 25. This is 1.257 10 to the power 5. 50 into 95 cube divided by 12, 35.72 for 10 to the power 5. $95 into 50 or 73.98. 1.257 10 to the power 8. So that's why we will take common 10 to the power 5 divided by 10 to the power 5 multiplied by 2 plus 35.24 plus 0.35 40.1746 or 40.1746 into 10 to the power 5 mm raised to 4. What is to calculate? Shown is 3 meter long. Simply support it at the end. Find the maximum UDL it can carry. So maximum UDL it can carry 3 meter. So M equal to, what is formula? WL square divided by 8. So this is 3 square multiplied by W that's why we'll consider this is and W, capital W. Three square means 9. 1.125 into 10 to the power 6 W. Right? Now, what is formula? Sigma B divided by Y max equal to, M divided by I. So here sigma BC, YC and sigma BT, YT, M into I. M equal to 1.125 10 to the power 6 W. I equal to 40.1746 10 to the power 5, and this sigma BT equal to tensile 30 and YT equal to 46.02 10 to the power 5. This is 55 73.98 M equal to. So which is less, that value we can apply 1.125 into 10 to the power 6. So this is sigma BT equal to, this is 30 megapascal and this is 55 megapascal. So this is already given 40.10 to the power 5 W. So that's why W equal to 55 into 40.174 divided by 73.98 multiplied by 10 to the power 5 divided by 10 to the power 6. This is equal to 2.98 kilonewton meter, and that is 30 into 1746 multiplied by 10 to the power 5 divided by 40.062 divided by 1.125. This is 30 into 40.1746 divided by 2.6189. W equal to 2.6189 kilonewton per meter. So this is your answer. So I did small mistake here. This is actual square. This is actually square. So that I did mistake. So that's why this answer slightly change, because this term 46.02 square multiplied by 42.13 10 to the power 5, and this is 73.98 minus 47.5 square multiplied by 95. This is 33.33. So that's why this value change. $33.3, 35.724 plus 42.13 plus 0.953. So this is 113 into 1. This value change 113 1. So this is 2.61. And this is 30, 113.1, 10 to the power 5 divided by 46.02 divided by 1.125 divided by 10 to the power 6. This is equal to 6.553 kilonewton per meter, and this is 113.1 into 55, 73.98 divided by 1.25, 10 to the power 6 multiplied by 10 to the power 5. 55 into 113.1, 10 to the power 5 divided by 73.98 divided by 1.125 divided by 10 to the power 6. 7.474. So that's why the load can be applied, UDL can be applied. This answer 6.553 kilonewton per meter. And this is your expected answer, because this is greater, otherwise this may be failure. So these are the different problems related with the bending stress. So due to limitations about the times, and I cover all varieties about the problems related with the bending stress. So in the next class we can start. The next chapter is the shearing stress above the this is the second part above the fourth unit. So that's why today I stop here, and we will continue next chapters shearing stresses in the next class. Thank you.